Hello everyone, welcome to Wind Down Friday. Today our special guest is Gajendra Prasad Singh, the CEO of Ambient Scientific. Hi Gajendra, welcome aboard.
Thank you for inviting me, Marcio. It's a pleasure to be here.
Thank you. Thanks a lot for your time. It's a great pleasure to have you at Wind Down Friday. Where are you located, Gajendra?
We are in Silicon Valley, California,
Mhm.
USA. The company is headquartered here in Santa Clara, California, USA.
Good, nice. So you are known also GP Singh in the community.
Yes.
I have prepared a couple of questions in this Wind Down Friday episode. So let's start talking about your company, Ambient Scientific. So it was born with a specific vision. So can you share the early story of co-founding the company? Tell us more about Ambient Scientific.
So, Ambient Scientific, just an introduction, is a fabulous AI chip company,
Good.
and we build a particular type of AI chips, which is called microprocessor class AI chips. Microprocessor class chips are one of the most complex chips that get designed. You
Yeah.
probably already know.
Yeah.
So we are doing AI microprocessors, and like most microprocessors, we build what will be called the microprocessor core. We call it MXX core or DGAN cores. Both names we use interchangeably, and these cores can be multiplied many times,
Yeah.
one time or thousands of times, to build a very small or very large chip. So we have an entire roadmap of AI microprocessors. The first one of them is called GPX10. This is a complete SoC with 10 of our DGAN core or DGAN AI cores. And then there are other circuitry, other peripherals to make it a complete system on chip. The first one is designed with the ability or with the vision to run AI on battery
Okay.
operating devices. You may know that AI, in general, AI computing consumes a lot of power.
Yes.
Achieving performance in AI or running AI algorithms consumes a lot of power. That means, in general, it was believed before us that AI programs or AI algorithms cannot run on battery, or it cannot. The battery operated devices cannot really have advanced AI. Our vision was to change this perception,
Okay.
and we have been able to achieve it. So our value proposition that we are bringing on the table is that without compromising the performance, or actually improving the performance, we reduce the power consumption of AI processing or AI computing dramatically, an order or two order of magnitude better. So our customers can achieve both performance and also low power simultaneously. This is our special value proposition. And because it's a microprocessor class technology, means it is extremely flexible and hundreds of applications can be built using our technology. So the vision of this company is to build very efficient AI processing that extends the performance limitations that we face currently, and that is affordable. So it can even go in small devices. Maurizio, when we started, our thinking or our vision was that every electronics in the world in next decade or so will have AI computing in one or the other form. Of course, at that time, that seemed like a wild idea, but you see now happening everywhere. Every electronics system is talking about AI
Yeah.
computing in one or the other way.
Thank you.
So we are making affordable, efficient, without performance limiting AI computing happen with flexibility and programmability. All the good stuff.
Nice. Thank you. So, Ambient Scientific's chip architecture so claims to combine as also you mentioned, analog and digital computing with the goal to solve specific issues, specific bottlenecks of on-device low power AI. So we are talking things like power efficiency, throughput, sensor fusion, and so on. So may you analyze, can you walk us through a specific trade-off you had to make when integrating analog compute components with digital ones, and how this would impacted the real world applications?
Okay, I will explain it. Allow me a couple of minutes here to give you the
Sure.
background. So when we talk about computers, we
Mhm.
have in past 35, 40 years, we have moved on to build computers fully digitally. We actually incorporated more and more and more digital technology. Even if there was an analog, we converted that to digital
Mhm.
because digital is easier to design, is more reliable. The when we analyze the AI computing or AI workload, Maurizio, what we found is that 95% of these algorithms or these programs was just one mathematics. This is very different from a classical computing where the computing is more limited, is actually a lot of many functions. But in AI computing, 95% of the workload is what you would call MAC, multiply, accumulate. Now, when we look at digital implementation, Maurizio, digital implementation of a multiply accumulate is actually very inefficient. Implementation of a digital multiplier by definition is very, very inefficient. It's actually, it takes more area, it consumes a lot of power using what is
Got it.
called. So when we looked at analog is for in general for computing, analog is not good
Mhm.
for most of the computing except one, that is multiply accumulate.
Mhm.
So analog computing is a perfect fit for multiply accumulate. So we decided to use analog. However, in general, analog circuits, Maurizio, are they're considered unreliable. They can also be unstable. They can give you unpredictable results. So to change that behavior to make them more reliable as digital computers or as a digital computing, we changed many of the pieces of that classical analog into digital. So we kind of formed a hybrid format. By doing so, we are able to retain 80% of the advantage of analog and remove its fatal flaw, that is unreliable and unpredictable behavior. So now we have this new technology, this is our own creation, which uses a hybrid form of digital and analog and is able to produce reliable results just like digital and efficient just like analog.
Really nice. Thank you. So let's talk about you in terms of so looking back. I mean, so what was when we are talking about AI, electronics engineering. So looking back, what was the earliest memory that pulled out towards this subject, electronics engineering, AI? So was it a book? What is a person, mentor, a moment, a device, a gadget? So what about?
Uh, Interesting question, Mauricio. But my interest in computer and especially in computer hardware goes back to school days. I was born in a country. I mean, I was born in India,
Yeah.
family where becoming an engineer or a doctor was the dream, and those were only two reasonable profession where one could feed his family reasonably at that time.
Yeah.
I'm talking about 80s. So obviously you choose between becoming a doctor or engineer to pursue your dream. I chose engineering. And in engineering, I was always very attracted to electronics in general. So I was lucky enough to get electronics engineering. There in India, you don't always get what you want. You have to compete for everything at that time. Now it's become much better, of course. So I was lucky enough to get into electronics, and then that was my journey. From there, went to France, then came to here to USA, and then have been here since past 25, 30 years. Multiple companies, was lucky to get some very good opportunities, Mauricio, and getting to learn and design microprocessor is again a very lucky thing. It's a lucky break. I was lucky enough to get into that and learn many pieces of microprocessors. So when this opportunity came, where the compute paradigm was changing so much so that you needed a completely new computer architecture from ground up, I signed up.
Thank you. Thanks for sharing. So if you had to describe the future of AI microprocessors in one sentence for the next generation of engineers, the young people, so what would it be?
Uh, it's going to be everywhere. If you use electronics, which, now we use electronics everywhere. When we walk, when we talk, when we sleep, when you watch, you're resting every
Always.
time with electronics. And we are in a new era of a different design environment, a compute paradigm. It's going to be everywhere, whether you're doing software or you're doing hardware or you're just an user of software or a computer or a small device. You will be using AI in next 20 years, Maurizio.
Hmm.
Uh, First, the most of the innovation you will see that today AI computers are very big. They
Yeah.
consume too much power. They are not fast enough. They will become a lot more faster. So you will see humanoids, more intelligent humanoids come up. You will see industrial electronics become far more efficient, far more, even things like agriculture or whatever we do on day-to-day basis, they will become far more uh, efficient, organized, and also a lot of human problems will
Yeah.
be solved. Safety problem, our first device that will be announced end of this year is going for human safety. It will be in a form of a pendant which one can wear, and it will last for months on a single coin cell battery, and it will be able to inform you if your elderly parents or somebody loved one is in emergency. And we are launching that. One of our customers is launching that by end of this year. And similar life-saving, life-assisting devices are coming up with our first chip. Our second chip will be able to bring the computing, Maurizio, efficient computing down to your smartphone, your laptop, whatever your large server is doing today. In next 10 years, you will see that happening into your smartphone, which is the trend.
Thank you.
Uh,
Great. And so a typical question that I ask to speakers during Wind Down Friday is, okay, is the following. So, okay, we are talking about semiconductors, technology, AI, but beyond technology, outside of semiconductors and technology, what passions, hobbies help you unwind? So to recharge the battery, so to keep you creativity. So tell us a bit about you from so beyond the semiconductors, beyond AI.
So, first of all, I'll answer this in two parts. I'm also extremely lucky for another thing. My hobby and my profession seems to be the same thing. I actually, even as a hobby, I like designing stuff, electronics or mostly electronics, computers, software.
Nice.
So it's kind of nice. However, my second passion is music.
Wow.
And that's what gives, you said everybody needs recharging.
Yes.
I mean,
Which
Mm,
music do you like? Are you playing guitar?
no, I'm not lucky enough to play any instrument
Okay,
very well. Listening to music, mostly classical music.
nice, nice. Thank you. So, GP, in conclusion, so the last question is so let's conclude in this way. So, if we would like to meet again for another Wind Down Friday in 2030, so in the next 5, 6, 7 years, so what would you hope AI but also the chips that you are building today have achieved for humanity by then?
So 2030 or 35, when we would be meeting again, Maurizio, we'll be talking, that I have this robot that is helping my parent or somebody. It's still too big. It's not fast enough. The battery doesn't last for 5 years. It seems to drain out in just 2 years. That's not good. That's what you'll be talking at that time. Uh, you would be complaining if those things cost you more than an iPhone. Today, of course, they cost thousands and thousands of
Yeah.
dollars. They don't even exist. So you will be talking in that language. You will be talking about a lot of diagnostics, wherein
Okay.
if you had a little bit fever, you should be able to run a lot of stuff at your home before you
Mhm.
go to the doctor. You would have a lot of these reports that will be generated. You will be guided to. I would think a lot of medicine availability will be guided by how these automated softwares are able to diagnose you. Those policy changes will happen. So in 10 years, the discussion will be focused on it's what is the next convenience I can get out of this. Like my agriculture, you will have a TV debates going on that in so and so country the crops died and the computers were not able to predict. Why not? The computers are not good enough. They should have predicted and we should have done something about it. What you will be talking at that time also, Maurizio, is that what is the next frontier in
Mhm.
how to solve the computing problem or how to make the software
Okay.
more efficient. And that is where I would think we would face a lot of trouble
Mhm.
because CMOS is so far the only compute paradigm you see where we can build intelligent chips. I don't see an alternative emerging yet. A lot of people are very excited about quantum, but for me, any compute paradigm is viable paradigm when we as common people can use it.
Okay.
If I can use it like my small phone or smartphone or my microwave, I can use it in my house. That's when that technology is viable technology. That, in my opinion, is still 30 to 40 years away. So at that time, there'll be a huge debate, hopefully a lot of investment also in material science research.
Yeah,
So
and AI is important for scientific for science material as well.
yes, but I think by that time, Maurizio, AI will not be a special name. It will become so ubiquitous. Like we are wearing shirt, you're wearing glasses, we are combing
Mhm.
our hair. Nobody talks about this anymore. It becomes so ubiquitous that it becomes so normal, natural
Yeah.
that people will take it for granted.
Okay. So thanks a lot. Thanks a lot for this opportunity. It's been a pleasure to have you at Wind Down Friday. I wish you a great weekend. So stay in touch. I will see you in some next conferences, and take care and see you next. Thank you so much.
It's all mine, Maurizio. Thank you very much. You've been very nice on the show. So thank you very much for your, being so courteous and nice and great questions.
Thank
Thank
you.
you.
Bye.
Bye bye.